Psych class. Welcome back for another Flex Time review. The topic of today's lesson is going to be sensory thresholds. Let's get started. Remember, all of our senses contain what is known as sensory receptors. Sensory receptors are specialized cells that are unique to each sensory organ that respond to a particular type of sensory stimulation. Energy from an environmental stimulus activates a specialized sensory receptor cell in a particular sense organ. Then these sensory receptors use a process known as transduction to convert the physical energy into a coded neural message. The neural message is then decoded by the brain and interpreted into a meaningful message. We are constantly being bombarded with many different environmental stimuli. At this very moment, multiple sound and light waves are passing through your body as we speak. However, sensory receptor sites are highly specialized, so they are sensitive only to a very specific type of energy. The energy of the stimulus has to be in a form that can be detected by our sensory receptors for transduction to occur. Our sensory receptors are going to work in other ways as well. Unfortunately, we as humans do not have an unlimited capacity to detect stimuli. A stimulus first must be strong enough for our sensory receptors to detect. A sensory threshold is going to be the level of strength a stimulus must reach to be detected. Sensory thresholds are a huge topic of study in the field of psychophysics, which is the branch of psychology that deals with the relationship between physical stimuli and mental phenomena. There are two general kinds of sensory thresholds for each of our senses. The absolute threshold is going to be the smallest possible strength of stimulus that can be detected half the time. So I'm guessing your first question is, why half the time? This is because the minimum level of stimulation that can be detected will vary from person to person and also from trial to trial. You will notice this in a minute when we do our absolute threshold test. Because of this level of human variability, psychophysicists have arbitrarily set the limit as the minimum level of stimulation that is detected half the time. As I have previously mentioned, these thresholds apply to all of our senses. This means that we're going to have a threshold for our taste, touch, vision, hearing, and smell. In 1962, psychologist Eugene Galanter tested certain stimuli until people were able to detect it during 50% of the trials. After several trials with multiple participants, Galanter came to provide the following historic examples for the absolute threshold of each of our senses. On a clear, dark night, a candle can be seen about 30 miles away. The scent of a single drop of perfume can be smelled after it has been given time to diffuse through 3 rooms. In a silent area, hearing the tick of a watch from about 20 feet away, the taste of a single teaspoon of sugar after it's been distilled through 2 gallons of water, and last, feeling a fly's wing drop on your cheek from about 3 feet. Yeah, save the weird one for last. So if you were to replicate this experiment with a bunch of your buddies, you would be able to detect each stimulus 50% of the time after multiple trials. And remember, your results might not match up 100% with your friends. This is due to the human variability that I discussed earlier. So how about we put the absolute threshold to test in a little experiment? Alright, so let's get going with it. For our experiment, it is your goal to detect a real word that is going to be presented in between 2 nonsense words. On the projector, you will see a plus sign. Focus on this plus sign. The word ready will flash, and about a second later, I will present the words to you. So as you saw from the experiment, nonsense word, real word, nonsense word, you have to detect the real word. Alright, so now we're going to start the actual experiment to test your absolute threshold. Keep in mind, the presentation is going to be much quicker this time around, so I hope you're prepared. Round 1, go. Alright, as you can see, that was much quicker. 33 milliseconds to be precise. So how about we take a look at the slow-mo replay to see what our word was. So according to our slow-mo replay, the word was sense. If you got it right, good for you. If not, don't worry, that was very quick. So for this next trial, we're going to slow it down a bit. Alright, so let's get started with round 2, go. Did you see the word this time? If you saw tacos, you got it. If you didn't, but for some reason you had a desire to go to Taco Bell, we will talk about why that happened in just a minute. For what it is worth, I have that desire all the time. Alright, so let's slow it down a little bit more for this next trial to about 150 milliseconds. Round 3, go. How about that time? Did you see the word Teddy? A shout out to my super good boy. If you did, great job. If not, stick around for one more round and we'll slow it down to about 250 milliseconds. Round 4, let's go. Alright, so 250 milliseconds gives you a lot of time to see the word smell. I would guess that those giving their full attention, a high percentage of you saw it. So chances are, some of you watching this were able to pick up on the word in earlier rounds, quicker than others. To find the true absolute threshold, I would run a test like this on you multiple times. I would then graph the relationship between the stimulus and the detection speed. On the y-axis, we have our percentage of correct responses, while on the x-axis, we have time. Adding our data to the graph, we can then see what the absolute threshold is. Stimuli located outside of our absolute threshold is considered supraliminal, meaning that we are consciously aware of it. Stimuli located below the absolute threshold is considered subliminal, meaning that we are not consciously aware of it. However, according to some studies, even though not consciously perceived, the stimuli can evoke brain responses. Now, if I flashed a logo of Chick-fil-A multiple times during this video, which I did, 3 times actually, would that mean that you're all of a sudden ready to drive out, get yourself a spicy chicken sandwich deluxe with pepper jack cheese, no tomatoes or pickles, and a side of honey barbecue? Probably not. Numerous studies have shown that subliminal messages produce no real change in behavior under controlled conditions. As I mentioned previously though, subliminal messages can evoke some type of brain response. The mere exposure effect states that repeated exposure to a stimulus leads to an increased liking towards that stimulus. This holds true for subliminally presented stimuli as well. In studies where participants were exposed repeatedly to a geometric shape, subliminally, and asked moments later to pick a shape from a group that they liked the most, the participants were much more likely to pick the subliminally presented shape. So while an interesting topic of study, it has been shown several times that subliminal messages have no real effect on behavior, as in an advertiser can't effectively subliminally message you into buying a product that you have no intention of buying otherwise. You may have noticed that while talking about the absolute threshold, we were only dealing with one stimulus at a time. But what happens when we're dealing with multiple stimuli? This is where our second type of stimulus threshold comes into play. The difference threshold is the smallest possible difference that can be detected between 2 stimuli half the time. The difference threshold is also referred to as the just noticeable difference, or the JND. Now for this next experiment, I'm going to have multiple circles on the screen. One of these circles will slowly start to fade to black. When I say go, a timer will start and the circle will slowly start to change colors. As soon as you notice a change, I want you to pause the video and take note of the time. Alright, ready? 3, 2, go! Alright, so if you still can't tell, here was our circle that changed colors. Let's try this test one more time. Everything is going to stay the same except for one tiny change I want to make. We're going to change the starting color from a dark gray to a crisp white. All other things remaining the same. Ceteris paribus for my econ friends. Let's get started with round 2. 3, 2, 1.5, go! Alright, so I'm going to go out on a limb here and say the second time around it was much easier for you to pick up on the change. Why might this be? Well, according to psychologist Ernst Weber, the size of the just noticeable difference will vary depending on its strength to the original stimulus. In our first test, the difference in change was relatively small, going from dark gray to black. While in our second test, the difference in colors were complete opposites. We were able to pick up on the difference much quicker because of the strength, or lack thereof, the color black had to our original stimulus of white. So there you have it. Sensory thresholds. You're practically a psychophysicist now. Not really. Anyways, I'm out of here. I'll see you guys next time. Peace.